Greetings to everyone. Here we are going to discuss about conduction of experiment number 7 of your basic electrical engineering laboratory. The name of experiment is determination of efficiency of single phase transformer by direct load test. Aim of experiment is to conduct load test of single phase transformer and determine its efficiency using resistive load. In this experiment, direct load is connected to the secondary side of the transformer. Initially, the load should be kept at 0 position. We have to apply the rated voltage to the primary winding of the transformer. Next, by varying the load in steps, so we have to note down all the meter readings connected to the transformer, and we have to tabulate the value for each step of load variation. The load should be varied till the rated current flows through the secondary winding. Once all the readings are tabulated, we are going to calculate the efficiency of the transformer for different steps by using formula. Next, apparatus required for this experiment is given below. We need a single phase transformer. The rating of the transformer is 2 kVA. We are going to use this transformer as a step down transformer. That's why the range of voltage is 230 bar 200 volts. In this experiment, we are going to use single phase shell type transformer. So while discussing in the theory classes, we have come across that transformers can be classified into two types based on construction, that is core type and shell type transformer. In core type transformer, the windings are wound on the side limb of the transformer, or we can say that the windings will be encircling the core. In the shell type transformer, the windings are present on the central limb of the transformer, or we can say that the core is encircling the winding. So in our experiment, we are using single phase shell type transformer as a step down transformer. Okay. Next, apart from this, we need voltmeter to measure the voltage. AC voltmeter of range 0 to 300, 2 numbers. Next, we need AC ammeter 0 to 10 amperes, 2 numbers. We need wattmeter 300 volts, 10 amperes, 1 number. We need a single phase auto transformer to vary the supply voltage, that is 0 to 250 volts, 15 amperes, 1 number. We need a variable lamp load and DCSC switch. This is a circuit diagram for conducting the experiment. So we can see that in the circuit diagram, all the equipments and instruments are represented symbolically. Okay. So here we can see that from the single phase AC supply, the connection is or input is given to auto transformer. From the auto transformer, the connection has to be made to ammeter here. From the ammeter, the connection has to be given to the wattmeter M terminal. And from L terminal, the connection has to be given to the zero tapping of the primary side of transformer. Okay. Next, M and C should be physically shorted by using a wire. Next, from 230 volt tapping of primary side of the transformer, that should be connected to auto transformer. Then voltmeter should be connected across auto transformer itself. Next, from the wattmeter V terminal, so we have to connect it to 230 volt terminal of primary side. This is about the primary connection. Means in the transformer, the winding which is connected to the supply side is known as primary winding. The winding which is connected to the load side is known as secondary winding. Okay. So next, look into the secondary side connection. From the secondary connection, that is from the 0 terminal, the connection has to be given to the DC switch. From the 200 volt terminal, the connection has to be given to the DC switch. So in the secondary side, we can find the different tappings on the transformer. So since the maximum voltage is 0 to 230 volts, in order to get 200 volts, we need to give the connection to 86.6% tapping. From that tapping, the connection has to be taken out. Okay. Then we need to connect one more voltmeter across the transformer secondary. Next, from the DC switch other end, the connection has to be made to ammeter. From the ammeter, the connection has to be given to the load. From the load neutral point, the connection has to be written back to DPSA switch. This is about circuit diagram. Next, we will look into the conduction of experiment and how the circuit actually looks like and how we are going to take down the reading.
Greetings to everyone. Today we are going to discuss experiment on single phase transformer. The aim of this experiment is to determine the efficiency of the transformer. The transformer, whatever we have considered here, it is a single phase shell type 2 kVA transformer. You can see that the circuit connection as shown in the circuit table. Okay. So from the auto transformer terminal, connection has to be given for ammeter. Okay. From the ammeter, the connection has to be given to the wattmeter M terminal. M and C terminal of wattmeter should be connected. Okay. From the L terminal, the connection has to be given to the 0 of transformer. You can see here. Next, from 230 volt, the connection has to be given back to the auto transformer. Then we have to connect V1, that is 0 to 300 volts across auto transformer terminal. Next, that is a primary side connection. Next, coming to the secondary side connection, we have to connect it for 0 to 200 volts. So in order to get the 200 volts, we have to use 86.6% tapping. Okay. So from 0 and 86.6% tapping, we have to make a connection to DPSA switch. On the secondary side, in order to measure the secondary voltage, we have to connect 0 to 300 voltage across, that is 0 and 86.6% tapping. Okay. Next, from the other end of the switch, the connection has to be given to the ammeter, that is 0 to 10 amperes. From the ammeter, the connection has to be given to the common point of the load. So since we are making this load as a single phase load, we have to short all R, Y, B phase here. Okay, from that common point, the connection has to be given to the ammeter. From the neutral point, again one more connection has to be given to the switch. Okay, so this completes our circuit diagram. So let us see the procedure for conducting this experiment. So we have to follow the procedure whatever given in our lab manual. Okay, first we have to switch on the supply mains. Okay. Next, by varying this auto transformer, we have to apply the voltage such that this V1, voltmeter V1 reads the rated primary voltage. So here the primary we have considered it as 230 volts. So we have to slowly vary this auto transformer. So you can see that you can observe the deflection in the voltmeter. So we have to adjust this voltmeter to 300 volts. So we have to take lower scale. So while adjusting the voltage.
After conducting the experiment, for each step of load variation, we are going to tabulate the value. The tabulation of the values is as shown in the observation table. You can see here for different load conditions. So here maximum load current is 10 amperes. We are going to load the secondary side of the transformer in steps of 2 amperes, 4, 6, 8 and 10 amperes. So for each step, we are going to measure V1, I1, V2, I2 and input power. And for each reading, we are going to calculate the output power efficiency of the transformer. In order to calculate the output power, so the formula is given here, that is P0 is equal to V2 into I2 into cos phi. Since it is a resistive load, the power factor of the load is taken as 1. So I have done the calculation for first reading here. For the first reading from the tabular column, you can observe that the current in the secondary side is 2 amperes and the secondary voltage is 192 volts. So that is nothing but 2 into 192 into 1 is nothing but 384 watts. Next, percentage efficiency of the transformer is calculated as percentage efficiency is equal to power output in kilowatts divided by power output in kilowatts into 100. That is nothing but P0 by Pi into 100. So in this case, that is the first reading, the power output of the transformer is 384 and power input from the tabular column, we can observe here from the direct wattmeter reading, that is 450 watts. So that is 384 divided by 450 into 100 will give you the 85% of efficiency. Okay. For every reading, we are going to calculate the efficiency of the transformer. From the reading, we can observe that the maximum efficiency is observed almost when the current is equal to 80% of the load current. Means from this we can conclude that the maximum maximum efficiency of the transformer is achieved when the load current is 75 to 80% of the rated current. So this is how we are going to do the experiment, conduct the experiments on single phase transformer and calculate the efficiency of the transformer for the different load conditions. Thank you.